Hello viewers, welcome to this exciting video. In this video, we will be looking at the November 2020 Science Paper 1, question B5. Question B5 reads, Figure B5.1 below is a diagram showing a wave traveling along a spring in the direction shown. Figure B5.1 below is a diagram showing a wave traveling along a spring in the direction below. So the direction we've been given is this direction according to the question. So that is the direction in which the wave is moving. All right. Then we've got two parts which have been labeled U and W. So U is this part and W is this part. Okay, so these parts W and U. So so let's see what the question asks of us. So B5A, in what way is this wave the same as a sound wave? In what way is this wave the same as a sound wave? So let's look at the diagram so that we get more. So what it is that this is a spring wave. Okay, it's a spring wave. So as the wave travels in the direction shown in this direction, the particles in the spring are moving to and from. To and from. So they are going in this direction, then again they move in that direction. So the particle is moving like this while the wave moves forward. So we can see that the movement of the particles is parallel to the movement of the wave, and any wave whose movement of particle is parallel to the movement of the wave itself, that wave is a longitudinal wave. And knowing what type of a wave sound waves are, we can actually say that sound waves are also longitudinal waves. So one ways in which the two waves, sound and the waves moving in that spring, are the same is that they are both longitudinal waves. So they are both longitudinal. They are both longitudinal waves. They are both longitudinal waves. Okay, so they are both longitudinal, but is there any other way in which they can be similar? Okay, yes. Since they move to and from, so they will have regions similar to U and W. So even in sound, we will have places where the particles come close to each other and areas where the particles are further apart. So areas where the particles are close to each other like U are called compressions. So these are compressions. And areas where the particles are further apart, these are called rarefactions. So these are called rarefaction. So compressions and rarefactions. So it means that both have regions They both have compression regions and rarefactions. These compression regions are called regions of high pressure, while rarefactions are regions of low pressure. So they both have these. So if you don't want to say they are both longitudinal waves, you can even say they both have compressions and rarefactions. They both have compressions and rarefactions. That is also a similarity. The third similarity is that they both require a medium. They both require a medium. For this wave to exist, it needs the existence of the spring. For sound to exist, it needs a medium such as air or gas or even liquids. A vacuum, it won't happen. So those are some of the similarities. So let's go to B. What are regions U and W called? So we've already actually looked at that. So we have U being compression. So these are compression. And W are rarefaction. The most common mistake that is usually made on rarefaction is that people will say rarefraction. They put an R between the F and A. There is no R, it's rarefaction. Okay, so we've got compression region and rarefaction. So we've got those two regions. All right, we come to C. Explain why sound waves travel faster in liquids than in gases. Explain why. So the key term there is explain why. We need to explain. And what are we explaining? Why sound waves travel faster in what? In liquids than in what? Than in gases. All right. The basic principle here is that the closer the particle in that particular media, the higher the rate at which the wave is transferred from one particle to another. So we need to state the fact that in liquids, the particles are close to each other compared to what? Gases. Okay, so particles in liquids are closer to each other than gases. Therefore, sound waves travel faster in liquids than in gases. So the reason why sound waves travel faster in liquids is that particles in liquids are closer to each other than in gases. All right, so the reason why sound waves, so sound travels faster in liquids than gases, right? Than in gases because particles in liquids are closer together to each other than in gases. Okay, there. So particles are are closer to each other than in gases. So this makes sound to be transferred faster in liquids than in gases. So that is our 5 marks for question B5. Thank you very much for watching. If you like the video, if you have any concern, don't forget to leave a comment. If you like the video, don't forget to give it a thumbs up. If you're new to the channel, don't forget to subscribe. See you next time when we look at question B6.